Hi guys, so today is a special day. Today is the Independence Day of Ukraine, and for that purpose we have a special t-shirt. It has Ukrainian coat of arms on it, but so yeah, very nice one. But we are here today for a different reason, of course. We are here today to solve some problems. And specifically, somebody asked me if I'm open to problem suggestions, and I am definitely open. I would like to solve the problems that you want me to solve, as long as they are of appropriate difficulty. So, for example, these two are just right. We will try to solve these two today. Because they more or less fit within the difficult range. Maybe we'll solve two of these later. So if you also have some problems that you want me to solve, definitely leave a comment, or you can also message me in my Discord server. And as long as they are of appropriate difficulty, which is like expert/candidate master for, let's say, Monday, Tuesday, and then a master/international master for Wednesday, Thursday, and grandmaster level problems for Friday, that should be fine. So just message me, and if there are like only two suggestions, then I will look at them. If there are more than two suggestions, I may have to choose. So yeah, I'll try to choose the more interesting ones. But hey, like, if somebody wants me to solve them, they must be reasonable, right? Let's check. So one problem comes from an educational code forces around 75, so a long time ago actually. Let's see what we need to do here. Hopefully with that you should be able to hear me a little bit better. So we are the head of a large enterprise, and people work at you, and n is odd, not divisible by 2, in case you don't know what odd means. When I was young, I often confused odd and even, but then I realized that odd has odd number of letters in it, and even has even number of letters in it, so that's how I remembered. We have to distribute salaries to your employees. Initially, you have S dollars for it, and the I's employer should get salary from left eye to right eye dollars. We have to distribute salaries in such a way that the median salary is maximum possible. Okay. To find the median of a sequence of odd lengths, you have to sort it and take the element in the middle position after sorting. Okay, that's why n is odd. To not think about what happens to median when it's not great. It's guaranteed that you have enough money to pay the minimum salary. Okay. Don't have to spend all your S dollars on salaries. That is interesting, because it means like S can be greater than sum of all right I's, and we'll still be fine. So the answer always exists. But of course, like, if you can pay all maximum salaries, then just go ahead. That will increase the median as much as possible. We have to answer t-test cases and do something. Okay. 1251D. It sounds a lot like binary searching over the answer. I mean, like, what else can you do? You sort of want to... So what I imagine to be the optimal solution is to pay exactly median to half of the employees plus 1. So if n is equal to 7, then we pay exactly median to half of the employees plus 1. And then we pay minimum salaries to everyone remaining. So that's how I would approach this problem. The thing is, I do not know in advance what value of m can be, But it turns out that I don't have to. Like, I can take a value of m and check if the corresponding sync is constructible. And that's just it. That is just it. Well, there are several details that we should be careful about, but overall that should be just binary search over the answer. First one is n, second one is long, sum, of course, long. We read both of them. We have a vector of pairs, left, right, there are n of them. We read them as well. I guess that's not particularly interesting to hear my commentary about reading input, but here we are. Okay. So what I'm thinking is that we have low salary. Median is strictly is at least 0, I guess. And at most 10 to the 9th. Let's go with okay. Like I need to add 1 here because it is possible that we have enough money to pay $1 billion to everyone. So, and high should be a value that is never possible. So now we will do our binary search while that is at least greater than 1. Check middle to be low plus high. And notice that like I did not want to put 2 here because then this doesn't work. Like of course you can write low plus high minus low over 2, but I just like it this way. I also like it the bounds to be as strict as possible. That usually helps. So if we can have a median of at least middle, and low gets assigned middle, otherwise high gets assigned middle. And the invariant is that low is always it's always possible to have a median of at least low dollars. So we will and never possible to have a median of at least high dollars, so we always output low. Now we need to implement our check function, which will take middle in, I guess. I can actually call it median or whatever. We'll return a boolean value. I think that we may need to sort, guys. The guys. What do we sort on is a question, is a good question. Now naturally I want to pay minimum salary to guys who have lowest possible low value, right? So I should be able to just sort on left, But then the thing that is worrying me is like the guys with real low values may have really high values, and you actually don't want to pay them like let me give you an example. So like imagine that we have a guy 1 3 1 3 and the guy who has a median salary of 2 that is from 2 to 2. When we check for 3, right, we check if it's possible to have a median salary of 3. I described that we want to take like if we just take this body, give him minimum salary, then we won't be able to get that body 3 because that's out of his range. What we actually should choose is 3, 3, and 2. So I guess that it's unclear what we should sort on. It's unclear. We can try to do it with a linear pass. Let's think what we can do. So one thing we can say for sure is that if a guy has right upper bound of his salary lower than median, then we always take his lower bound, right? So what I want to check is for every segment, if right is less than median, then this body can't possibly help. We will pay him can't help in making median salary at least that. So we will pay him minimum salary. Otherwise, let's have we have a vector like otherwise we are interested in what is his minimum salary, because I already said that we never pay more than median. So what it means that if we check in the value of 3, let's also say that this guy has max upper bound of 4. So all intervals that fall below, we will just assign them their minimum value. Now all intervals that remain, we will kind of change their maximum value to the median because we never overpay. But then, like, because all of their right values are the same and equal to median, we can just store their left values, which happens here. Now we have to think about this set, and hopefully that will help us. So I'm pretty sure that we want to sort that. That is fine. That is log squared. We don't worry too much about it. It's probably possible to have like one sort for all. They don't exactly see how to do it like straight away, so we'll just stick to the plan. Log squared should be fine. Log squared should be fine. With the following intention, we need at least n over 2, n plus 1 over 2 of these guys to take median salary. So So let's grab the length of this guy. If len is less than n plus 1 over 2, okay, let's not be ridiculous. If len is less than, then we can return false, because even if we pay everyone who has that salary, who can't possibly get median salary, it won't help because there won't be enough of them. Otherwise, we want to take half of the bigger guys. So what we'll do is for this body, from that to that, if I is less than half, it means that we are looking at the guys who should get median. Otherwise, remaining less equals LMI. That sounds about right. Let's see if that actually works. That sync, I don't care. Oof, that will be hard to. No, 11, 13, 37, and 6. I guess we do that. I hope that n log n is fast enough. Log squared is fast enough, right? People don't usually die from an extra log factor. Okay, that is more interesting. I wonder why. I mean, like, there are several places which can go wrong. First number differs. Okay, expected 68, found 79. Wait, do we have like 19, right? 19 is what? 19 is n. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 18, 19. Okay, that is... Oh, okay. So I need to print one, then that, and then, okay. And they say that I can only achieve 68 or what? Right, so they actually say that our answer is higher than it should be. Oh, okay, interesting. Yeah, you can see that output is 79 and their answer is 68. So it means that we mistakenly think that we can get a median of 78. Why is that not possible? So imagine we got 79 in our binary check, right? So it will look like here. Okay, that is potentially possible. So that gets into our set, that gets into our sets, same. That can't possibly be good, so that gets a value of 10. That can be good, can't be, so potentially can be. That can't be good, so gets this. Everybody else can be good. Oh, okay. I think that the wrong thing here is that we are not being careful. Let's copy that. Right, okay. So I think that if right is less than median, we also have to check our left is greater than median. And it can't possibly help, right? Because like there were guys who were like 100 to 100. They don't help much. Interesting. So now we are getting that. Why is that? Oh, okay. We are not being careful once again. You see, half. Well, let's say what we want. Want at least that many people who have a salary of at least median. So this happens, but also this happens. Where is the? I want that that sample. Okay. Now we are being a little bit more careful. We don't do stupid things. Because yes, of course, like that cropping that I described, that we get rid of right endpoint and change it to median, it only works if we can actually do that if median is within the segment. So let's try again. Okay, so far so good. Maybe leave, however. They wanted something more intelligent here, but I don't think so. Okay, yeah, so you can see that log squared is fine. You probably can get rid of this and sort only once, but like, hey, why would you want to write more codes, right? So, people don't usually die from an extra log. They do sometimes die when it's n square root of n and they try to add an extra log. But hey, like that is an extra log, and this is fine. I'm 99% confident that you can solve this problem in of n log n time and not of n log squared n time, but this 1900 probably because of you that you can't solve it. So yeah, more or less reasonable problem. Like you could only do one thing here, which was binary search over the answer, and that solves the problem. You have to be a little bit careful though. Like you consider three types of segments. One can't help with median, so they should get minimum salary. Others can't help with median like others by default help with median. So you process them and you also give them minimum salary. And among remaining ones, you want to greedily choose so that some guys, like there is a fixed number of guys that we want to get at least median salary. So let's pick them in a way such that this sum of remaining guys, we can pay minimum salary to them because we already satisfied the median property. So we want this, like this is median times want. We don't care about it. We could actually try to do something like that. So we start from want and we subtract that. And we will also subtract median times want. That should be also fine. I mean, right? Interesting. Why is that? What happens? I did literally nothing and it broke. Fascinating. No, but the difference is just... What's the difference? I will also need that actually. Can I compare? Like, that's the difference. And for some reason that is runtime. Oh, but what happened, guys? I don't get it. Why is that runtime? Oh, if want is negative. Oh, if want is negative. If want is negative, then yeah, that is okay. Okay, very interesting. So yeah, in fact, if want is negative, then you of course can't use negative indices here. It may happen if you have like very low values of median. That means that a lot of values got picked no matter what. So yeah, interesting. Yeah, but overall that's a nice, easy binary search over the answer problem. I hope that makes sense. So like once again, you consider 3 types of segments. 2 of them you pick minimum salary because there is no point in picking anything else. And the rest you pick greedily, and you can also sort within your can function binary search. That's legal. Let's take a look at the second problem that I've been suggested. It comes from a D1 Rod. It's problem B. Xenia and colorful gems. So Xenia is a girl being born in novel. Okay. Okay. Due to the inflexibility and harshness of her family, Xenia has to find some ways to amuse herself. Okay. Recently, Xenia has bought NR red gems and G green gems and NB blue gems. Each of the gems has a weight. Now she's going to pick 3 gems, loves colorful things, so she will pick exactly 1 gem of each color. Loves balance, so she will try to find pick gems with little weight and little difference in weight. Specifically, supposing weights X, Y, Z, and we pick those. Okay. Okay. Sounds interesting. Sounds like geometry, but hopefully it's not. Red and blue. Red, green, blue. Red, green, blue. So I think we want to find the smallest guys, right? Wait a second. Is it again binary search over the answer? Is it? Is it? Is it? I don't know. I hope not, but we'll see. Should we merge the guys and then have some sliding window? That sounds very reasonable. I mean. So let's think, if we merge the guys and then have a sliding window, we want to find the minimum window that has all 3 colors. For each such minimum window, we want like 2 endpoints are obviously of different colors, so otherwise the window is not minimal. So we have 2 endpoints of different color, and we want to find whoever is like the closest to the middle guy from the 3rd color, which we hopefully can do. Great. Yeah, just slide a window. Okay. I will have to think about how do we represent guys. I think we can use just std set. Okay. Develop our all red guys. We select OK. A gets in place back. We can also call a resolve. Red, green, blue. What do we in place back? We in place RI and then let's say 0. Not a very interesting problem, unfortunately, I think. Here we should insert 1, here we should insert 2. We then sort we then have what? We then want to have a sliding window and 3 sets, I guess, of red window, green window, blue window, because we'll need to find more or less the median in it. The median, well, luckily for us, we can overvalue, so we can use just std set lower bound, right? But that is an annoying problem, to be honest. Really, really bad. I mean, I guess that's something you have to deal with sometimes, but yeah. Okay. Value. So the value can be long, that's for sure. So what the maximum value that we can have is that 3 that times that. I think it is. Let's add a little bit more, just in case. Okay. Right goes up to. I should just call it the N for short. So what do? We do the following. Is it guaranteed that reds are distinct? Well, we don't care. That is also worrying me how this is red and that is red. Okay. And I want to print minimum, obviously. So, if A right, so first of all, we want to add right in. Okay. Now, how do we want to do that? So we say, like, okay, if A right, second is color. If color is equal to 0, color is equal to 1, color is equal to 2, now you can probably have a vector of 3 sets, right? That will probably be better, but what's our, we already typed too much code. So going to go back, so if this happens on red, waits. I already forgot why this is letter W, but if this happens, then I want to insert this first. Here I want to insert into greens, here I want to insert into blues. That will just save us so many typos. Okay, so we inserted that, and then we want to that is not empty, and that is not empty, and that is not empty. So annoying. I should have had. Okay, whatever. That will be worse, as you will see. So I have vector set active of size 3 with the following intention. So instead of doing all this madness, we will say active at a right second insert a right first, instead of all this madness. So here we check if not active they are not empty, all of them. Now we can, okay, also do it like this. If active color empty, I usually don't do that, but that sounds like a nice application of this. Like we'll continue if that is not empty. So at least one of them is empty, then we'll skip the following part. Oh no, that does not help much, right? Oh, I hate this problem so much, or oh, it appears to me that this is what you have to write. Well, this can be probably simplified. So active at a left second, we erase a left first. Now, what you want to check is like, you know that this is one of the endpoints, one of the colors, right? Now this is the other color. So now that the third color is the remaining one can be determined like that. Because the sum of all colors is 3. Now what we want to say is we want to say that minimum gets minimum of minimum, and well, one endpoint is that, other endpoint is that, and the in between, so middle should be between those two guys. Want to call, okay, so like we want to call lower bound on actually active color, lower bound on middle. All right. I wonder how quick is previous. Like, usually I would just say that I want this. Not nice. Like, I want to check from both sides, you understand? And obviously I can also keep track of like negative values, but that is so annoying. So annoying. You can't even imagine. Okay, I just want to see if the previous offset is actually slow. Oof, but I also, oof. So if iterator is not equal to active color and you can call a function like this. And I don't know, we'll have it somewhere like here. X, Y, Z, I believe is the terminology from the problem. I did so much. No, okay, that's a good practice. That is a good practice. Keep calm. The previous one I liked it better. Okay, here I want to check if iterator is not equal to active color begin. Then I can take bit and I can say like, okay, let me call that in. So bad. That is so bad. I can't remember the previous time when I implemented something that was so bad. Oh, I said it in template again. 1336B. Hello, excuse me. Okay. Oh, nice. Line 8. Oh, I didn't. Okay. So 44, 41, 44. Okay. How did that happen to us? Well, in this case already breaks, right? Let's have it run once again. Yeah, this already breaks. Why? I don't know. Okay, okay, this may not be like valid if someone was empty. Well, f equals false. Like f equals true. If f is set, then we want to do something here. That makes sense. So like, you can't do anything if your window is not full of colors. It does not contain all three colors, right? Oof, that's tough, that's tough. Implementation is tough, the solution, not so. Okay. We're still breaking on the same test case. Why is that? Are we breaking if I just comment that out? No, we are not, we just print maximum value. By the way, we should be actually extra careful. Say if this has such element, then erase it, because that's a set, not a multi-set. So yeah. I don't understand what can go wrong here. Let me just take an iterator. What can go wrong? Iterator can be AND, right? But that's fine. Because we checked explicitly against it. Okay, so this one actually already breaks, so something here breaks. Oh my goodness, oh my goodness. I don't know how that happened, guys. We were not advancing cars, sliding window. Okay, now it does not break, please. The answer appears to be incorrect. Because we got 2 here, which we should not get. We also got this here. Which we should not get. How did that even happen? Okay, we'll leave it as is. I don't understand, like, how do we even get such values? They are clearly incorrect. How did that even happen? How did we get value 0 and 0? No, I don't understand how you can get values 0 and 0. No, but like, so the last value is usually non-zero. A right first. But A left minus 1 first is 0 for some reason. Also, iterators are often small. So how is that? Okay, that can be actually 1. That is very questionable. It is a position, and then comes the color. The second is the color. Color. And first is the position, and we just print that, and that is incorrect. That it says that this is always 0 for some bizarre reason. It can only happen if left minus 1 is an illegal index. Fascinating. I probably should add also +1 here. it does not really matter. Why is implementation so painful for this problem? It's not intended to be complicated, right? Well, you can see left is 1. Quite often, actually. Yo man, I'm so tired right now of looking into this. What's going on? Like, I just don't understand. We have our position, we have our color. How the heck they become zeros? So annoying, honestly. What the fuck is that? Oh my goodness, I'm an idiot. I'm an idiot. How can I be so bad? By the way, I guess okay, yeah, we can also do that. No. This way it will look to look better. So answer 14, 24, 24, that body and that body. 14. How many idiots? Okay. That's so sad actually. We can try submitting just this, but I think that it will has a little bit too much debug output. So we'll submit this version instead. And hope that it does not get run answer too. Is this, whoa, I actually forgot that we have std pref, which may be slow. Is that what it is? Is it TL? No, okay. So surprisingly, std pref for std set works not in linear time apparently, but in logarithmic time, which is nice to know. Okay. I feel like it's necessary to explain this approach in a little bit more detail. So what I did, I allocated all the gems on the line. And then I have a sliding window. So I say like, okay, like your body are left, your body are right. Does this window contain all colors? Not so. This one, not so much. How about this one? Still not. Okay, how about this one? Oh, yes, it does. And I said, like, okay, I'll have to, like, these guys are of different colors. Because that's the first time we contained all colors, so this one must be of a new color. Therefore, these two guys are of different colors, and we can uniquely determine which color is the remaining one. And ideally, we would like it to be here, straight in the middle, because you can just write this expression. If, let's say, x and z are constant, then it's quadratic in y, and its minimum is clearly x plus z over 2. So we take that, so we say like, okay, we want to find the closest this way and closest this way. For this, we'll need to keep those guys, red guys, in a set, which supports lower bound, which we'll find as this body. If there is no one here, we will take the previous one and we'll check that one as well. Actually, even when there is somebody here, this one may be just better because it's closer to the middle. So yeah, and because we don't know which color will be in the middle in advance, we'll have to keep an std set of active positions for all three colors. So that's what we do here. And we just check if it's true that, like, while this is just sliding window and this one corresponds to like finding the middle element. First we need to restore color, then we compute middles, and we'll look in our set, which make sure that we check previous as well, make sure that iterators are valid, stuff like that. Not particularly interesting. But hey, sometimes you gotta do what you gotta do. I originally wanted to do some more problems from there, but hey, like, I assume that we had enough already. The video will probably end up being like 1 hour long, so even more. So I guess that's enough for today. Once again, you can see that like 1700 rated problems can be tricky, but keep in mind that that's a D1B. So in D1 rounds, everyone is like highly skilled. They can solve this problem. So this problem is like lower down. I think the rating is a little bit lower than it could have been if that was proposed as a problem in Div2 rounds. I was also wondering whether there is another approach, like this thing I needed it because, like, well, So I don't know which color will be the middle one in advance. What if instead I loop over other guys? So like I loop over the pairs of colors. One is left, other is right, and I can know which one is in between. I can sort of merge these two together and then find the closest to middle, but I saw that it's more or less the same as this sliding window. So not the best problem in the world, but once again thanks for the guy who suggested it, because sometimes you gotta do what you gotta do, and that is just one of such cases. Like, you know that some sort of sliding window will work, and then you just make sure that you keep the correct data structure. Make sure that you work with iterators right here, here, here. You make sure that you actually erase what's there. A lot of details to this problem that I don't like, but overall a nice problem for hopefully like you learned something new. I guess you could have learned that like you can keep custom data structures in your sliding window. That's important. Specifically, it's important if you can, it's very useful if you can keep a data structure that supports a lot of logarithmic operations, because then overall you get n log n. It's fast. And here, like, well, the binary search does it. Binary search plus greedy. And there will like this observation that you're looking for middle is just mass, so you need a little bit of mass as well. Oh, that is actually incorrect. Let me delete template, because that's always gets in the way. Yeah, that nice trick with enum when like you're sure that you're inserting the right value. We can of course get rid of it. It actually simplifies the implementation quite a bit. Let's try to make it like more shorter and less bad, I guess. So here, instead of having this, we can have vector int n. Okay. K is just one constant, that's always 3. That is so subtle, like forgetting to put a reference in. We can straight away fill the vector A if you think about it. Here n is actually accumulate. Well, all you can call accumulates, but you accumulate of here. Let's make it capital N. Loop our colors up to K. We say that we read into AI first and I second. No, loop our colors. Okay. So we have index I, we also have current color. So, okay, we don't have that, No, we will need that. Okay, so for this from here to here, and color. Position. We have position, right? We read a position and we say A in place, back, position, and then color. We sort that. Here it's capital K, here it's capital N. This one I really want to make a generic, but like I don't exactly see how to do it. So we may as well just leave it like 3. Yeah, this one is already much shorter. But like it kind of does not make sense to generalize what is not generalizable solution. Like if you get 4 colors and I have no idea how to solve the problem, it will probably be much more complicated if you need 4 colors. Because like you need to choose 2 in between. How to do that? That's a interesting and complicated question. Have to find the optimal value given a window. Well, I don't know. Let's try that actually works as well. Just quickly check. And I'll let you go, I guess. Not waste any more of your time. This scope is not necessary. I agree. Well, technically we can also say like reserve n. It makes it a little bit faster, not much. I can say that it's more or less the same. The memory usage decreased because we don't have temporary vectors for red, green, and blue gems separately. That's a little bit like less nice than this. This one was just very nice. This one is well done. You got to do what you got to do. I'm surprised that previous off in a set works fast. I mean, it should work, but STD standard library and all often does not do what it's supposed to do. STL. So yeah, once again, I hope that you learned something new from these 2 problems. Maybe you learned that you can store a data structure in your sliding window. Maybe you learned that you can have something logarithmic in your binary search predicate. It also works. And with that, I'll see you tomorrow with some more complicated problems. You are free to suggest them, but keep in mind that like we can't solve easy problems every day. So tomorrow we'll have something around 2000 rated at least. That's it. Like keep in mind that when suggesting problems, but definitely you're welcome to suggest more and more problems. We'll look through them together. So thanks everyone for watching, and I'll see you tomorrow. Bye bye.